Hello friends, how are you? Hope you are all healthy and happy. Have you ever wondered about Junkers Ju-288? Today we're diving deep into this topic, and by the end you might just have all your questions answered. The Ju-288 was developed as part of Germany's Bomber B program during World War II. Before the war began, the Luftwaffe's bomber fleet mainly consisted of planes with modest capabilities, many of which were initially designed for civilian purposes. The Ju-88 stood out as the only genuinely advanced model in their collection, surpassing other models in performance. However, it faced several issues, one of the most significant being its tiny internal bomb bay. This limitation meant that part of its bomb load had to be carried externally, which hindered its speed and performance. Was something new needed? The Junkers Ju-288, initially known within Junkers as the EF-074, was a German bomber project developed during World War II, although it only saw action in prototype form. The first model took flight on November 29, 1940, with a total of 22 developmental units produced. This aircraft emerged as the top choice in the Bomber B competition, a contest largely influenced by Junkers through their submission of the EF-074. The Bomber B initiative aimed to replace the Junkers Ju-88 and create a Schnellbomber, or fast bomber. The Ju-288 presented a design that was not only larger but also featured cabin pressurization for high-altitude missions, extended range, a significantly larger bomb capacity, faster speeds, and enhanced defensive capabilities. Was it envisioned as a replacement for all existing bombers in the Luftwaffe fleet? To meet these ambitious specifications, the aircraft required much more powerful engines. At various stages, all Bomber B designs depended on the Junkers Jumo 222 engine for this enhanced power. However, the Jumo 222 ultimately proved unsuccessful despite extensive efforts and multiple redesigns over several years, with nearly 300 prototypes developed. Could no adequate alternative engine be found? This shortcoming led to the downfall of the Ju-288 program, leaving the Luftwaffe to rely on older bomber models in the latter half of World War II. Before World War II began, the Luftwaffe's bomber fleet was comprised mainly of three types: the Dornier Du-17 and Ju-88, both categorized as Schnellbomber, or fast bombers, and the larger but slower Heinkel He-111. The Ju-88 outperformed other models in service, but had drawbacks, such as a very small internal bomb bay that necessitated carrying part of its bomb load externally, reducing its efficiency. Since 1937, Junkers had been developing improved versions of the Ju-88, equipped with either the Jumo 222 multibank engine or the Jumo 223 inline multibank diesel engine. These engines were designed to deliver a significant power output of 2,000 horsepower, 1,500 kW, a considerable challenge for the German aviation engine industry at the time. Was the EF-074 essentially an enlarged Ju-88, maintaining its basic structure but with an extended fuselage and wings? The aircraft featured a redesigned, more aerodynamic stepless cockpit without separate windscreen panels for the pilot and co-pilot, facilitating easier cabin pressurization. This design became increasingly popular in German aircraft, notably in the He-111 P&H models. The defensive armament of the Ju-288 was designed to be remotely controlled. Was one proposal archived on April 13, 2014, in the Wayback Machine? It included a remotely operated rear-facing dorsal turret at the end of the cockpit glazing and two remotely operated flank turrets on the fuselage near the empennage, similar to the FDS L-131 units used in the Mi-210. Did the use of remotely operated turrets for the Ju-288's defense not only allow for more efficient positioning, but also help maintain the integrity of the fuselage pressurization? To accommodate a significantly larger bomb payload, the fuselage was lengthened, similar to the modifications in the Dornier Du-217, which was under development at the time. This expansion enabled the aircraft to carry a 3,630 kg 8,000 lb payload internally, eliminating the necessity for external ordnance hardpoints. Although preliminary designs existed, no substantial progress was made on these versions until Heinrich Hertel, previously with Heinkel, joined Junkers in 1939. Was it under his guidance that the EF-074 design was presented to the German Air Ministry (RLM) in May 1939? Subsequently, in July 1939, did the RLM issue specifications for the Bomber B competition, retroactively designating the Ju-88 as Bomber, a label previously assigned to the He-177 per the June 3, 1936 specification. The Bomber B program aimed to replace all medium bombers in the Luftwaffe with a new model based on the EF.74 or a comparable design. This new bomber was expected to surpass the Ju-88 in speed, feature high-altitude capability with a pressurized cockpit, possess heavier defensive armament, cover any target in the British Isles with its range, and carry a warload of 4,000 kg, double that of earlier generation bombers. Did several companies submit proposals for the Bomber B program, although the EF.74 was already favored to win? Of the other designs, did only the Focke-Wulf FW-191, Dornier Do 317, and later the Henschel HS-130, as a late entrant, progressed to the prototype stage. Prototypes began construction soon afterward, with the first completed by mid-1940. Initially was the plan to power these aircraft with twin 24-cylinder Jumo 222 engines, each offering over 1,500 kW of output. However, due to developmental challenges with the Jumo 222, were the first prototypes equipped with BMW 801 radial engines instead. Were the first flight-worthy Jumo 222 engines not available until October 1941, and even then, were they far from ready for mass production. As it became evident that the Jumo 222 would not be a feasible engine option, did Junkers propose in May 1942 to use the heavier Daimler-Benz DB606 engines for the planned Ju-288C model. These were the same dual crankcase engines that Reichsmarschall Hermann Göring criticized for their numerous issues, particularly in relation to the persistent power plant troubles of the He-177. Was the design of the Ju-288's main landing gear system complex and problematic? It featured a unique arrangement where each gear unit had twin vertical elements forming a main Y-shaped retraction strut, situated behind a single oleo strut. Was each set of twin wheels mounted on a forward extending lever action arm attached to the lower end of this distinct main oleo strut. This oleo strut, pivoting from the lower end of the Y-shaped retraction strut, would rotate backwards during retraction, independent of the twin member unit, reducing the gear's length when stowed in the engine nacelle. Did the top end of the oleo strut, which moved freely, have to rotate downwards and backwards during the retraction of the main Y-shaped strut? Was this movement controlled by a lever and gear sector system located on the port side of each main gear assembly? The system, operated by a long lever pivoted from a bracket attached to the firewall's rear surface, swung the oleo strut around its attachment point during retraction, moving it through an arc of approximately 180 degrees from its fully extended position. In the stowed position, was the oleo strut oriented backwards within the rear of the engine nacelle, with the wheel axle situated just ahead of and above the oleo strut's pivot point when fully retracted? Was this complicated design, with only a single pivoting point for the oleo struts bearing the primary impact of touchdown, likely one of several issues that caused the Ju-288's main gear units to repeatedly fail upon landing? Was the cancellation of the Junkers Ju-288 program a significant decision, marked by technical difficulties and shifting priorities during World War II? Initially envisioned as a state-of-the-art medium bomber under the ambitious Bomber B program, was the Ju-288 plagued with persistent technical challenges, with its engine being the most notable? Did the intended Jumo 222 engines, crucial for achieving the aircraft's desired performance, face continuous developmental hurdles? Were these engines, designed to provide superior power and efficiency, unable to meet expectations, leading to delays and underperformance in prototype testing? As the war progressed, did the Luftwaffe's needs and strategic focus shift? Did the prolonged development and inability to resolve the Ju-288's technical issues mean that resources allocated to the project were increasingly seen as unjustifiable, especially given more immediate wartime demands, with German aircraft production under significant pressure? Were priorities given to projects that could be quickly realized and had immediate combat relevance? In addition to engine problems, did the Ju-288 also struggle with other design complexities, such as its intricate and problematic landing gear system? Did these technical difficulties compound the delays and escalate the project's costs? By 1943, did it become clear that the Ju-288 was not going to meet its objectives within a reasonable time frame or budget? Did the Reich Air Ministry decide to terminate the Ju-288 program? Was this cancellation part of a broader rationalization of Germany's aircraft production efforts, aimed at concentrating resources on a smaller number of aircraft types that could be more reliably produced and deployed? Did the discontinuation of the Ju-288 program allow the Luftwaffe to redirect its finite resources to other projects, particularly those promising more immediate returns for the war effort? Thus, did the Ju-288, which had once promised much as a next-generation bomber, end its journey as an experimental prototype, never realizing its intended role in the Luftwaffe's arsenal? In the post-war period, did the Junkers Ju-288, despite its failure to reach operational status during World War II, garner interest for the advanced concepts and technologies it had introduced? Did Allied forces, particularly the United States and the Soviet Union, show a keen interest in examining German wartime aviation technology to glean insights that could apply to their own aircraft development programs? Was the Ju-288, with its innovative design elements, part of this scrutiny? Was one of the key aspects of interest in the Ju-288 its advanced aerodynamic design, featuring a streamlined stepless cockpit which offered improved aerodynamics and visibility? Was this design approach later seen in various post-war aircraft? Was the Ju-288's attempt at incorporating a pressurized cabin for high-altitude operations another point of study, as it was a significant step toward developing aircraft capable of effectively operating at higher altitudes? Were the aircraft's complex and ambitious engineering, particularly its power plant and landing gear system, also subjects of analysis? Although these systems proved problematic and contributed to the project's cancellation, did they represent forward-thinking engineering that pushed the boundaries of existing technology? Did lessons learned from these systems' shortcomings inform future aircraft design and development, helping to avoid similar pitfalls?